Magnetic field of a solenoid. In figure, sectional view of long solenoid is shown. Consider a rectangular closed path ABCDA as an Amperian loop. Here, sectional view of long solenoid. Cross represents that current is entering and dot represents that current is coming out. Now we consider this Amperian loop and we try to find out the value of magnetic field inside the solenoid. So let's apply Ampere circuit law. So closed integral B dot dl. So for this purpose, we break this loop into four parts: A to B, then B to C, then C to D, and then D to A. So we write it from A to B and B dl, and the angle between magnetic field and direction the wire is running or current is running is 0 degree. So cos 0 degree. Then B to C, here theta will be 90 degree. B dl cos 90 degree. Then C to D, B dl cos 180 degree. Then D to A, B dl cos 90 degree. This is perpendicular, this is parallel, this is anti-parallel, this is perpendicular. Cos 90 is 0, so these two terms will cancel out. And here cos 180 is -1, but outside the solenoid magnetic field is 0, so this term will also be 0. Hence, we will get only one term. So integration B dot dl is equal to A to B, B dl, which will be equal to BL, where L will be length between A and B. Now, let the number of turns per unit length of the solenoid is N. Number of turns per unit length of solenoid equal to N. Then number of turns of length L of the solenoid in that length would be NL. Number of turns in length L will be NL. So we can say that current I of the solenoid threads the loop ABCD and L times. Number of times current threads the loop is NL. Now, total current threading the loop ABCD will be NIL. Total current threading the loop equal to NL times I. So we can say BL equal to mu naught NL I, which implies B equal to mu naught Ni. Here N is number of turns per unit length. Now graph between magnetic field and the length of solenoid is shown. Inside the solenoid, magnetic field is B, but at the ends, this value drops to half, which is shown here. So this is B by 2. So this is end of solenoid. So value drops. Now let's understand it by some numericals. Question number 1. A solenoid coil of 300 turns per meter is carrying a current of 5 ampere. The length of the solenoid is 0.5 meter and has radius of 1 centimeter, find the magnitude of magnetic field inside the solenoid. So we can write the information. We are given N equal to 300 turns per meter, and I is given as 5 ampere. We can apply the formula B equal to mu naught N I. The values, mu naught is 4 pi into 10 to the power minus 7 into number of turns per unit length 300 into current is 5 ampere. So this will give 1.9 into 10 to the power minus 3 Tesla. Now let's take another question. A copper wire having resistance 0.01 ohm per meter is used to wind a 400 ton solenoid of radius 1 cm and length 20 centimeter. Find the EMF of a battery which, when connected across the solenoid, will cause a magnetic field of 10 power minus 2 Tesla near the center of the solenoid. So let's consider the solution. Length of wire used equal to 2 pi r times number of turns. So the number of turns are n. So here we put the values 2 pi into radius. The radius is given as 1 cm, means 10 power minus 2 meter, times number of turns is 400. So this is length. Then resistance per unit length is given. Resistance per unit length is given as 0.01 ohm. So total resistance equal to length times resistance per unit length. So 0.01 into 2 pi into 10 power minus 2 into 400. So this will be equal to 8 pi into 10 to the power minus 2 ohm. Now, number of turns per unit length, we can find N equal to 400. Here this is total turns, not small n, instead of capital N. Now, number of turns per unit length, so 400 turns divided by length will be equal to, here length is equal to 20 into 10 to the power minus 2. In our question it is given length is 20 centimeter and total turn is 400. So it will come out to be 2000 turns per meter. Now we apply formula B equal to mu dot and I. So we put the values. So mu naught and I equal to E upon R. We have to find out E, and we put the values. So E equal to, we will get B multiplied by R divided by mu naught times small r. We put the values 10 power minus 2 times magnetic field is given here 10 power minus 2 into resistance. We have got this much 8 pi into 10 to the power minus 2 divided by mu naught. Mu naught is 4 pi into 10 to the power minus 7 into number of turns per meter is 2000. So let's evaluate it. So here everything will cancel out and we will get 1 volt. Thank you for watching.